glasses. Outer space, the universe, the sun and the earth beneath us all bombard us with radiation every day. I am a student at in the RPT program here at Aiken State Technical College, wherever we're at. And as a student, I am subject to a lot of information about this particular subject matter, and I do appreciate trying to speak on it. So I will talk about three things today. One is understanding of radiation, and it's actually that's not really that is what I'm covering wholly, is the fact that I'm talking about radiation, how it is good for our growth and development, as well as how it can be harmful to us. And I'm going to be talking about 3 points today. One, what is radiation? Two, where does that radiation come from? And three, how can it be harmful and or helpful to us? So first, I'd like to talk about radiation, and that would be a quote from the Nuclear Regulatory Commission, which is a government agency that has over 100 years of research in the field of radiation, and they have a basic, simple definition of radiation as being energy given off by matter in the form of rays or high-speed particles. Everybody might know about, well, might have common knowledge about rays, be it one of the, there's a wavelength. The atmosphere is completely made up of matter. And that matter consists of atoms, and although you can't see it, the air has atoms as well. There's radiation coming from everywhere, you just don't know it, you don't see it because of those rays. Sometimes that information is put in that matter, which consists of these atoms, which create the radiation, is everywhere around us. And I want to define what an atom is if you're not familiar with it. That being that particle, that matter that most of us can't see. It consists of a proton and a neutron and an electron surrounding it. Proton has a positive charge, neutron has a neutral charge, and an electron has a positive negative charge, thank you, that surrounds that nucleus. As an example, let me see. Radiation is created when a force, say a particulate, engages a nucleus. What I just did was create a sound wave, and that sound wave actually is radiation in itself because it is an energy force projecting outward to everywhere. And you hear it in the sound wave, which is one of the first waves that we recognize as being something. Whereas if you were to look at a chart, going into my second point, if you were to look at a chart of, not really going into my second point yet, but if you were to look at a chart that consisted of different types of waves, it would start off with radio waves, which is kind of that audio thing that I just demonstrated. Microwaves, which you're familiar with cooking, infrared light. Those are the three waves that basically you can't see. The next wave would be visible light, which is actual light. You can see it. That's what you're seeing. It's an actual wave that's created by photons coming through the air. Ultraviolet would be the next level up, and that would be the first step basically in a radiated wave. It is what you experience on an everyday basis in the sun, sending ultraviolet light down to you. It's the thing that causes a sunburn when you feel it. It's not radiating your body, it's heating up your body, and in reaction, you have a chemical reaction which causes that burn. But the next level up is an X-ray and then a gamma ray. Now, those two are actual radiated rays that are pretty much everywhere that you just don't see them. In my next point, I was basically trying to establish a measurement. There's a lot of different ways that you can measure radiation, and one of those is a millirem. And a millirem is, just as an example, we are exposed to about 620 millirems of radiation every day from anything, from everywhere, mainly coming from the Earth's core, but also radiation coming from food we eat, like a banana has radiation in it. The Earth has radon gas coming out of it, which is a natural substance created from the Earth's core, and it's all around us, and we breathe that in. There's also the cosmic rays and the sun rays that are constantly hitting us. So all these things are actually helpful in creating life. Radiation, like photosynthesis, maybe some of you are familiar with, is part of our life. So radiation has good effects and bad effects. So in conclusion, I have talked to you today about radiation and how it can be good for you and bad for you. Or I fumbled around that as much as possible.